All right, it's time for lesson 7-7. Getting closer to the end of this unit. Hopefully you have enjoyed it. I love the polynomial unit. Well, you probably caught on to that, I'm sure, during class. All right, so we're going to talk more about factoring today. And we're going to factor equations in the form of x squared plus bx plus c. Expressions in that form. And again, we know the purpose of being able to factor, right? We want to be able to factor these so that we can solve equations when they're in this form. You'll see when we get to quadratics how helpful this is. All right, so factoring this form of an expression, x squared plus bx plus c, when b and c are both positive. One of the easiest methods to use to factor trinomials, because that's what this is, I have 3 terms being added, is to use something called a factor sum chart. So basically when I say we're going to factor this, what I'm meaning is I want you to write it in the form of that, where I have 2 polynomials and 2 binomials that I'm multiplying together to get this. So I want to be able to write this in factored form. Now you might be thinking, well, didn't we already learn how to factor this? Don't we just look for the GCF? Well, in this, with these 3 terms, the largest amount that would go into all 3 of those terms, can you guess what it is? It's 1. So if I just pulled out 1, I'd have to write those 3 remaining terms inside, and we can't solve that the way that you have seen. I would just be setting that equal to 0, and you don't know how to do that yet. So I want to have it set up as 2 separate binomials. So how do you do that? All right, well, we need to figure out what amounts I can put in here that when I FOIL them out, I get this. And all you have to do is figure out, okay, well, what are some of the factors of the 16 that will give me the sum of 10? So the factors of C to get the sum of the B. That's what we're looking to do. Factors of C to get the sum of the B. I know, it sounds a little bit naughty, but it's okay. Okay, so let's think about what are some factors of 16. Well, of course, I can take 1 times 16. 1 times 16 is 16. Now, when I'm looking to get the sum of the b, that means when I add these factors together, I should get 10. But 1 plus 16 is 17. So that one's not going to work. Some other factors of 16, maybe you're thinking, okay, well, I know that 4 times 4 is 16. But is 4 plus 4 10? Nope, it's 8. I also know I can take, because this doesn't work yet, 8 times 2. When I multiply those together, I get 16. Is 8 plus 2 10? Yes. So that means I'm going to use the numbers 8 and 2. And it's as simple as now saying, okay, x plus 8 times x plus 2. And the reason I have that x there is because that's what it was in this original expression. And if you did FOIL that out, you'd have x squared plus 2x plus 8x, which is 10x, plus 16. So you can go forwards and backwards. It's a nice way to check your work. Once you get this resulting expression here, you should FOIL it out, see if that's what you got. Okay, so basically all you do when you get this expression, and every single one you're going to see today, the coefficient of the x is going to be 1. You'll learn in the next lesson what to do if there's a number in front of the x, because it's a little bit different in that case. So for now, they're all just going to have a coefficient of 1 for the x squared term, and the factor sum chart is what we're going to practice with today. So let's try a few of these. I'm going to zoom in a little bit closer here. All right. So I wanted to make a factor sum chart, and I want to know the factors of C. This is C, right? Because the form of the equation is x squared plus bx plus c. So the factors of 1, that will give me the sum of b, which is 2. So what are the factors of c that will give me the sum of the b? Well, the only factors of 1 are 1 times 1. And are the sum of those factors 2? Yeah, 1 plus 1 is 2. So those work. Because these are both addition now, I know that I have x plus 1 and another x plus 1. Do you know the best way to write that? What should you do? When you have the same amount being multiplied, we're going to write this as x plus 1 squared. If you left it as that, you wouldn't be technically wrong, but this is a better way to say it. All right, let's try another one. I want the factors of c, which is 8, that give me the sum of the b, which is 9. Well, I know that 2 times 4, those are factors of 8, but 2 plus 4 won't give me 9. I know also that 1 times 8 is 8, and 1 plus 8 is 9. So although there are other factors of 8, those are the factors of 8 that when I add them together, I get the sum of the b. So my resulting expressions, or my resulting factored form, would be x plus that 1 and x plus that 8. And we're done with that one. All right, last one like this. All right, I want the factors of c to get the sum of the b. So what are some factors of 24? Well, maybe you think, well, 6 times 4 is 24, but 6 plus 4 is only 10. Well, 12 times 2 is 24, but 12 plus 2 is 14, so that's not going to work. Okay, well, 8 times 3 is 24. Hey, 8 plus 3 is 11. There we go. So you don't always get the right factors on the first try. You're trying to, but if you don't, it's okay. Your factor sum chart can look like that. So this means that 8 and 3 are the values that I'm looking for. So we're dealing with z here. So this one's going to say z plus 8 times the quantity of z plus 3. So far, so good, I hope. All right. Next, we have factoring x squared plus bx plus c when b is negative and c is positive. So in the last equation that we dealt with they were both positive. B and c were both positive. This time, if you have a negative b, the factors both have to be negative so that you can get a negative result when you add them. Isn't a negative plus a negative? That's going to give you a negative, right? So if you see an equation in the form of, I'll just call it a minus plus, why not, where the b is being subtracted and the c is being added, this means a negative b, right? That means it's a negative 8. So when you have a negative b, that means when you're looking for, we're still going to do this little factor sum chart, the factors of c to get the sum of the b. When you see this positive 12, I know that we're going to start wanting to do positive numbers like 4 times 3 and 6 times 2 and different amounts. But if you need to get a negative result and a positive c, the only way to multiply two numbers together to get a positive, but when you add them together it's negative, is to have two negatives. Because a negative multiplied by another negative is a positive, and a negative plus a negative is a negative. So again, when you see that b is negative and c is positive, instead of saying, well, I know 6 times 2 is 12, we're going to put negatives with it. Because a negative 6 times negative 2 is positive 12, but negative 6 plus negative 2 is negative 8. So one more time, when you see b is negative, that means that the factors of c that you're looking for need to both be negative. So when c is positive and b is negative, the factors that you're looking for must both be negative. So I'm going to write this as x minus 6 times x minus 2. And if you wrote plus negative, if you did this, that's okay. Also, maybe up here you said negative 2 times negative 6 instead. If down here you said this, it's the same thing as saying 2 times 4 equals 4 times 2. Those both mean the same exact thing. So the order of this isn't mattering. The digits that you choose, that's what matters. Okay, let's try a couple more of these. So notice I have a negative b and a positive c. So what are the factors of c that will give me a sum of negative 4? So positive c, negative b means these factors both need to be negative. Because the only way to multiply a combination to get a positive would be either two positives or two negatives. And if you make them two positives, you're not going to get a negative b. Okay, so 3 times 1, that's what we're dealing with, right? And then negatives. And when you take negative 3 plus negative 1, that is a negative 4. So my resulting expression would be x minus 3 times x minus 1. And I had said before, hey, you can double check this. You can. X times x. Oh, I used an x instead of a w. Will you please forgive me? Just pretend that's a w so I don't have to scribble it out. All right. X, or w times w, is w squared. And if you have this x times negative 1, that would be negative x. and then another negative 3x's, which will give you the negative 4, and a negative 3 times a negative 1 will be a positive 3. So all you have to do to see if, hey, did I get this resulting expression correct, FOIL it and make sure you get the original one. All right, one more of this, and then yes, there's more. My infomercial, but wait, there's more. Okay, I'm going to keep change this because I'm so used to it. I want the factors of C to get the sum of the B. Oops. All right. So we've got the number 24. 24 has a lot of factors. What are the factors of 24 that if I add them together I can get a 14? I hope you're thinking 12 and 2. If you toyed around with some other options, that's okay. You can have a factor sum chart with a list. But I know that 12 times 2 is 24 and 12 plus 2 is 14. I also know that to get this negative b, I need to make those factors negative. So my resulting expression, x minus 12, x minus 2, or if you wrote x minus 2 and then x minus 12, that is totally fine. It means the same exact thing. It is no big deal. All right, turn the page. I'll turn my page too. Here we go. Zoom out. Okay, same thing, factoring this, and again, all these have in common that the coefficient of the x squared term is 1. When you're trying to factor x squared plus bx plus c, when b is positive and c is negative. So last time when you did this, we had the opposite thing going on. We had a negative b and a positive c. Now, we're going to have a positive b and a negative c. Because the c is negative, the factors have to have different signs so that the product will be negative. The only way to get a negative product is to have one of each, right? When you multiply a positive and a negative, or a negative and a positive, that's the only way to get a negative. The higher digit needs to be the positive one so that the b is going to be positive. Because when you add integers with unlike signs, you take the sign of the higher digit, right? I know, all those integer rules that we said, they're super important. We weren't kidding. They're super important. At least we still get to do our factor sum chart. So I'm going to add the opposite with this. I'm noticing that, okay, the c is negative, the b is positive this time. I want the factors of c that will give me the sum of the b. Okay. Now again, I have a negative result for factors. That means I have to have one that's positive and one that's negative. And the higher digit needs to be the positive one so that when I add them together, I get a positive result. So when I say 21, I only see factors of 7 and 3. 7 times 3, that's 21, right? Now, the higher digit is 7, the lower digit is 3. Since I want a positive result, I'm going to put the negative sign with the 3. So 7 times negative 3 is negative 21, right? And a positive 7 plus a negative 3 is a positive 4. So my resulting expression for this, I'm going to have one of each. I'm going to have a positive, and I'm going to have a negative. And if you wrote x minus 3 first and x plus 7 second, it doesn't matter. It's okay. And if you wrote plus negative 3 instead, that is also okay. But if you put two addition signs in there, that's not okay. All right, next one, notice again, we have a positive b and a negative c. All right, so factors of c to get the sum of the b. It's a nice little poem there. Okay, again, when I look at 33, the only factors I really see are 3 and 11, which is good because when I subtract 11 and 3, I do get 8. So I'm going to go ahead and I'm going to multiply my 3 and my 11 here. And I know that one of these has to be negative to get a negative product. And I know that the lower digit needs to be negative so I can get a positive sum. All right. So I put the negative with the 3. Negative 3 plus 11 is a positive 8. That means my resulting expression will be x minus 3, x plus 11. And if you wanted to write x plus negative 3, we have discussed the fact that that is totally fine. And if you are a real go-getter, like I know you all are, you'll want to check it to make sure you're right. And this, again, I did the w. I'm just going to change that and make it an x for next time. But when you multiply those, there's the w squared. Then I have 11x and a negative 3x. You would subtract. There's the 8. And a positive times a negative gives you that negative. So just FOIL it. You don't even have to write it out. Do it in your head like we just did, and you can make sure that you're correct. All right, last one like this. Again, positive b, negative c. So the factors of negative 27, that will give you a positive 6. All right, with 27, I see 9 times 3. I hope you see 9 times 3 as well. Knowing your multiplication facts is super duper important with this stuff. So if you don't know your multiplication facts, please know it's never too late to learn them. Just go on Extra Math. Make some flashcards. You should know 0 through 12 multiplication facts inside out. Because a calculator is not going to help you figure this out. You have to know in your head that 9 times 3 is 27. So again, it's not too late to learn them. If you don't know them, you need to know them. Summertime project. All right, I need to get a negative 27 and I need to get a positive 6. So that means I'm going to put the negative with the 3 so that when I take a positive 9 plus a negative 3, I get a positive 6. So the resulting expression for this, that's a positive 9, so x plus 9, that's a negative 3, so x minus 3. And again, if you wrote it the other way, it's okay. Don't worry about it. Okay, one little application problem and then we'll be set. I'm trying to keep all these lessons under 20 minutes. I've been working really hard at that for this unit. So I'm about 16 minutes right now. This should not take 4. I'll stop talking about it so we can just do it. Okay, application. The area in square meters covered by a building can be represented by, and here is your lovely little expression here. Area, to get area, don't you need length times width? This expression doesn't tell me length times width. I ask you, what are the binomials that represent the length and the width? So basically, I want to know what times what will give me that. We're not looking for like 3 times 4 here. I'm looking for a binomial multiplied by another binomial. So with this, you do what we just did. We're going to go ahead and we're going to factor that. So we're factoring the expression x squared plus 7x minus 30. I'm going to keep change this. And I know when I need to factor, I'm going to go to the factor sum chart. I need the factors of C that will give me the sum of the B. Notice it's a negative here and a positive there. When you have a negative C and a positive B, that means one of the factors needs to be negative, and it needs to be the lower one that's negative so I can get a positive result. I know that 6 times 5 is 30, but when I subtract those, I'm not going to get 7. I also know that 3 times 10 is 30. That's helpful. And when I subtract those, I do get 7, but I need this to be a negative so that I can get a positive 7 there. So the result here, I have one of my side lengths would be x minus 3 and the other would be x plus 10. So we're not done. There's more. Like I said, always an infomercial. Now I ask you, okay, so these are the side lengths. This is the length and width of the building. I ask you not to find the area. I ask you to find the perimeter of the building when x is 15 meters. I think a picture would be very helpful. So let's make a picture. And I know it's not really going to be a square, but just bear with me. Okay, one of the side lengths of this we said is x minus 3, and the other we said is x plus 10, right? Perimeter is the distance all the way around this building. So I'm going to go ahead and I know that if I have something that's in the shape of a rectangle, that the sides are parallel and the same. So if this is x plus 10, so is this. And if this is x minus 3, so is this. So if I'm asking you, hey, what's the perimeter when x is 15? All you have to do is plug 15 in for x and add up all your sides. Meaning, for this one, I would take 15 minus 3, and that's 12, right? And if this side's 12, so is this one. And I can plug 15 in for x up here. 15 plus 10 is 25, and that means this is also 25. So to get my total perimeter, I'm going to add up all the sides, or I'm going to take a little shortcut and say 25 times 2 plus 12 times 2. If you put 25 plus 25 plus 12 plus 12, it's not, same number of digits. It's not really a shortcut. It's just a different way to look at it. So 25 times 2 is 50, and 12 times 2 is 24. So when you add them all up, we get 74, and the unit we're measuring in is meters. All right, 19 minutes, 22 seconds. Done. See you tomorrow.